Bismillah ar-Rahman ar-Rahim. My poor friends, my poor little friends, my angels. Today we will continue our study on chapter 9. We arrived to document 3 and its title is Nervous Message and Action Potential. Our objectives are an introduction first. We want to study the characteristics of the nervous message in a nerve fiber and in a nerve by interpreting experiments, and we'll draw conclusions. Then we will recognize some factors that affect the velocity or the speed of the nervous message, and the last objective is to compare the velocity or the speed of the nervous message in a myelinated and non-myelinated nerve fibers. So these will be our objectives in document 3. What is its title? Nervous Message and Action Potential. Please, first, before starting, I want you not to having misconceptions. The action potential is when the action potential propagates, it is called nervous message. Always the action potential propagates, and you know this. So when we create an action potential, this action potential will propagate. So we will give to it the name of a message, nervous message. The message that passes from one region to another. It's like this. So let us start in the name of Allah. And the remark, as I said for you now, nervous message is what? Is this negative wave that propagated before we explained it. The nervous message is the negative wave that propagates along the axon or the action potential. Do not forget, in one experiment, when we stimulated, we explained the deviations of the needles as what? As a negative charge that is moving. So this negative charge that is moving is the nervous message or the action potential. So when you create an action potential, this action potential will propagate, and it is given the name we will name it message, nervous message. In reality, in our study, as you saw in our objectives, we will study the characteristics of the nervous message in a nerve fiber and in a nerve. So one study of the characteristics of nervous message were in a nerve fiber first. What is the nerve fiber in general? Just till now, it is the axon. Okay. Later you will see that it may be the dendrite or the axon, but to facilitate the idea, okay, put in your mind it is as the axon. Now, in order to study the characteristics of the nervous message in a nerve fiber, we have to make an experiment, and this is the experimental setup used. What about this experimental setup is? We have, first of all, a nerve fiber, isolated nerve fiber, a nerve fiber, one nerve fiber. Okay? And what? We have the oscilloscopes, and you have electrodes. Look at S1 and S2. Look, S1 and S2 are called what? Stimulating electrodes. They are the electric wires of the adapter I will use to give electric stimulation for the nerve fiber. And R1 and R2 are the recording electrodes of oscilloscopes, O1 and O2 respectively. We have 2 oscilloscopes. Look to the R1 is inserted inside, and R2 of the oscilloscope O2 also is inserted inside the axon. Now, RE, you know it, before I named it, it is the reference electrode, and reference. It is in reality put either on the axon or in the region around the axon, because it is charged positively. It has positive charges. In reality, there is a difference يعني there is no initial or principal difference in principles يعني. If you put the electrode, the second electrode on the axon and you stimulate, the oscilloscope will give you two action يعني two drawings, upward and downward, like this, upward and downward. But if you put the second electrode in the region, in this case you will obtain such a recording. It is called monophase and not biphase. Monophase, one upward recording. Normally we use this connection okay, to facilitate things and to facilitate the study of the document. So we have the first oscilloscope and the second oscilloscope. These are the stimulating electrodes. So it seems like we will simulate the fiber. Yes, we will stimulate the nerve fiber. Look what? We will simulate this nerve fiber, okay? These are the reference electrodes. We will simulate this fiber 6 times. I1, I2, I3, I4, I5, I6. We will give 6 stimulations having the intensity from I1 to till what? I6. And these stimulations are of increasing intensity. We are increasing the intensity of the stimulation every time, each time we will stimulate. It means that I2 has an intensity greater than that of I1. I3, the intensity of I3 is greater than I2, and so on. We are increasing the intensity of the electric current we use to stimulate the nerve fiber. Good. Now what? We'll simulate and we'll observe the recordings. This part of the document show us the recording in O1, okay, and below this recording below is for what we will see on the oscilloscope O2. Okay? Before interpreting, and in our objectives we said we will interpret the experiment. Before interpreting, please look to the document. Look to the document. And please answer this question. Are all simulations producing an action potential? Very good. No, because we are not observing any action potential for I1, I2, and I3. But for I4, yes, we observe an action potential. Okay. But I1, I2, I3 are not producing action potentials. Look, they do not reach the threshold of depolarization. If you remember, we said if the intensity decreases to become minus 50 or minus 55, we will obtain an action potential. Okay, here minus 50, and sometimes minus 55, yes. So the threshold of depolarization depends on the type of nerve fiber we have. But in general, in animals, it is between minus 50 and minus 55. Okay, millivolts. Good. Let us start with our interpretation of the document or of the experiment. This is our experiment, and we want to interpret. Please pay attention. I will start like this. I will put together the first 3 stimulations. Okay, because they have the same result. So for simulations of increasing intensities, I1, I2, and I3, no action potential is obtained. So what? Now very good. So the intensities used are below the threshold or minimal intensity. خلاص النقطة انتهى. No action potential, it means that the intensity used is below the threshold. خلاص no. For simulations with increasing intensities I1, I2, and I3, O1 and O2, yes, O1, the oscilloscope O1 and O2 do not record any action potential, so the intensities used are below the threshold or minimal intensity. It is an interpretation. We made a relation between the result and the variable. Now what? A connector. I will take I4 apart. Who can know why? Who can answer this? Why I have to take I4 apart? Look to this. Please يا حبي. عمال معروف يا حبي. I4 is the first simulation that produces an action potential. What do you think about the intensity of the simulation I4? Is it below the threshold? لا يا استاذ على الاكيد منا below because it produces an action potential. But because it is the first simulation that is producing an action potential, maybe it is equal to the threshold. Maybe it is the minimal intensity, or maybe it is greater, isn't it? Because what? It produces an action potential. But I am sure that I5 and I6 that are greater than I4 are above the threshold. So for this reason, I will take the simulation I4 apart, because maybe the intensity of I4 is equal to threshold, maybe it is greater. But I5 and I6, I will take them together, because the intensity of I5 and I6 that is increasing, as I said at the beginning of the experiment, it is the intensity. Their intensity is greater than the threshold, of course. I am sure, certainly. So now what? I will write this. For this, on the other hand, a connector, if with the intensity I4 that is greater than I2, I1, I2, I3, an action potential what is obtained? An action potential of 100 millivolts is obtained, isn't it? Look to this. From minus 70 till plus 30, there are 100 graduations. An action potential of 100 millivolts is obtained. So I will now continue like this. So the intensity used for I4 is equal I4 O1 and O2 record an action potential of amplitude 100 millivolts. Yes. So I4 is equal or greater than the threshold. Also, there are two results here. How can we explain that? O2 also recorded the action potential recorded by O1. The action potential is recorded by O1 and by O2. It means that the action potential can move, propagates. Look to this. O1 recorded an action potential following the simulation I4. And O2 also recorded the action potential. For this reason, what I am telling in the relation that this is that, for simulation with I4 greater than I3, O1 and O2 records an action potential of amplitude 100 millivolts. So what? So I4 بالأول is equal or greater than threshold, and also the action potential can move, propagates along the axon. Why? Because we have in reality two results, two indications, two relations. The first, there is an action potential. It means that I4 is equal or greater than threshold, and O2, when it recorded the action potential, it means the action potential can propagate. Also, action potential propagates along the axon. Okay? Furthermore, what? Now, look to this. For I5 and I6, we are increasing the intensity of stimulation. But is the amplitude changing here? Is there any change in the amplitude of action potential obtained? No, very good. No, look to the same action potential. So we are increasing the intensity of stimulation. I5 and I6 are greater than I4. I5 is greater than I4. I6 is greater than I5 also, because we are using increasing intensities. But using these intensities also, we obtain the same action potential. So in a nerve fiber, when we increase the intensity of the stimulation, the amplitude of the action potential remains constant. Does that increase? It is a property. Furthermore, when we stimulate the fiber with increasing intensity I5 and I6, O1 and O2 record the action potential of same amplitude as for what? I4. Look to the document. For I5 and I6, same amplitude as for the stimulation I4. So, in a nerve fiber, when we increase the intensity of stimulation, the amplitude of the action potential remains constant. It is extremely important. Do not forget, the experiment proves that when you increase the intensity of stimulation above the threshold, the amplitude of the action potential remains the same, is not increasing. For this, we said that in our fiber, when we increase the intensity of stimulation, the amplitude of the action potential remains constant. It does not increase, it remains constant. This, let us say that. This is an interpretation of the experiment. In our objectives, if you remember, I put this in our objectives. Look what. Okay, in our objectives, I put this. Study the characteristics of nervous message in a nerve fiber and a nerve by what? Interpreting experiments, and will draw conclusions. Okay? So, we interpreted the experiment. Now, for this, we say that because of that, the nerve fiber has two possibilities. Either it will not give an action potential, no action potential if the intensity is below the threshold, or it will give an action potential with maximal amplitude that will not increase anymore. All the action potential, all the amplitude, because the amplitude will not increase even if you increase the intensity of stimulation. So what? We say that, as conclusion, the nerve fiber obeys the law of all or none. All the amplitude, if there is an action potential, all the amplitude is produced till the first time, it will not increase anymore, or there is no action potential. None means no action potential. All means if there is an action potential, the amplitude of this action potential will not increase anymore, even if you increase the intensity of stimulation. Okay, my friends? Okay, very good. Now, we are studying the characteristics of the nerve message in a nerve fiber, isn't it? The first characteristic, if you want, it is that the amplitude of the message, the amplitude of the action potential will not increase. The nerve fiber obeys the law of all or none. It is the first characteristic. Now, what about another thing we observed, we discovered here? We discovered that the action potential produced upon stimulating the nerve fiber will what? Will propagate, will move. So if I tell you something is moving, if I tell you something is moving, you will ask me another question about this movement. With which speed? With which velocity? What is the velocity of this movement? What is the speed of this movement? So when we say the action potential in a nerve fiber propagates, it moves, so with which velocity? Look to this. An experiment, a simple experiment was performed, was realized in order to find the speed of the action potential. In reality, we have approximately the same experimental setup as before. Here we had only 2 oscilloscopes, but here we have 3 oscilloscopes. You can use also 2 as you want. These are the stimulating electrodes. We will stimulate and look to the scale, 1 centimeter. The distance between S1 and R1 equals the distance between R1 and R2 and I say 1 centimeter. S1 and R1, 1 centimeter. S1 and R2, 2 centimeters. S1 and R3, 3 centimeters. And we have also recording of the time. It says why we have to know the distance and the time. Because ya hubbi, to find the speed, we have to divide, distance over time. We say 15 kilometers per hour. Distance over time. Like this, we find the velocity. We will simulate the fiber here. We simulate the nerve, and look what? Effective stimulation. What is the meaning of effective? Yeah, the intensity is equal or above the threshold. It will produce an action potential. Now, we stimulate the fiber And look what we observed on the oscilloscopes. O1, O2, and O3. Let me ask you first, what does this mean? This. Very good. It is the signal of stimulation. Yes, ahsantu. So we have this is the signal of stimulation. In reality, it is not an objective, but a culture. Culture. Please يا حبي اعملوا معروف. Please pay attention. It is a culture. يعني in life science section, we have to speak, we have to discuss. In reality, here we are using the electric current to stimulate the fiber. And we are using the oscilloscope to record. These oscilloscopes will record the action potentials as well as the intensity of the stimulation also. Isn't it? I am using the electric current to stimulate, and oscilloscopes are measuring the tension, measure the tension of electric current. So in reality, the signal of stimulation is in reality is the same as the intensity of the stimulation or the tension, as you want. It is an electric signal. Okay? Good. So once you stimulate using electric current, okay, the electric current you are using will propagate, will move. The nerve fiber is a good, and will conduct in a good way the electric current. So when you stimulate, the first signal here, the signal is the electric current used to stimulate the fiber. Okay? And the velocity of the electric current is very high. It is approximately that of the light, 300,000 kilometers per second. So, what is important, first, look to the signal. It is given in same time by the 3 oscilloscopes. Yes, because you are using the electric current to stimulate, so the electric charge, the electric current will move along the fiber, مثل كأنه electric wire الفايبر بالنهاية. So with very, very, very high speed. So it is as if it is reaching R1, R2, and R3 in the same time. It is important as a culture to look to this. Then what? After a given time, O1 recorded an action potential. After more time, O2 recorded an action potential. The same action potential is moving. And after more time, the action potential arrived to O3 and it is recorded by O3. Okay. First, let us finish our objective. What is the velocity or the speed of the action potential? Okay, it is the distance over time. So look to this. The distance between S1 and R1 is 1 centimeter. So I can say it is 1 centimeter, and after how many milliseconds, okay, the oscilloscope recorded the action potential? After 1 millisecond. This is the beginning of the simulation. After 1 millisecond, look to the scale, okay, the action potential arrived and it is recorded by oscilloscope O1. So the velocity is equal to 1 centimeter over 1 millisecond. Or if you want to use the recordings of the second oscilloscope, the distance is 2 centimeter and the time is, look to this, 2 milliseconds. It is the same velocity. Yani the speed of the action potential along the nerve fiber does not change. It's the same. It is 1 centimeter per millisecond or 10 meters per second or 10 meters per second. In general, it's an average speed because it depends on temperature, etc., many factors. Okay? Now, to finish. So only I want you as objective to know that the speed of the action potential is not changing, does not change when it propagates, and that the velocity is equal to the distance over time. Now, is the action potential an electric current? Is the action potential an electric current? I want you to tell me why it is an electric current or why it is not an electric current. In reality, yes, there, please, you can speak, yes. Very good. أحسنت، رائع. يعني أنت عن جد رائع. Very good. So please, let me tell you. Let me please. Thank you. Let me tell you. When I defined the resting potential and the action potential, I put the expression electric current between two brackets because it is an electric manifestation and not an electric current. Since there are two differences between the electric current and what the potential, the resting or action potential. Please, first, does the action potential have the same velocity? We calculated the velocity. قلنا the velocity is 1 centimeter per 1 millisecond. Is it the same velocity as the electric current? No. I said for you the electric current is of very high speed, approximately that of light. 300,000 kilometers per second. So the action potential and the electric current do not have the same speed. For this reason that the signal of stimulation was obtained in the same time for the three oscilloscopes, while the recording of the action potential is not in the same time. They take more time because it is slower, very slow with respect to the speed of the electric current. This is the first idea why the potential or the action potential is not an electric current. The second thing, very important, can you give me the definition of electric current? What is the electric current? What is the definition of electric current? روعة يا حبي. It is the movement of electrons. Do we have movement of electrons in the action potential or movement of ions? The action potential is due to movement of ions and not electrons, so it's not an electric current. We say the action potential and the resting potential are electric manifestations. They are not electric currents because they do not have neither the same speed or the same nature. Okay? Good. As I told you, it is a culture, only a culture. From this document here, I want you only to put in your mind that the speed of the action potential along the nerve fiber does not change, and we can calculate it by dividing the distance over time. Okay, my friends, I hope you understood what I explained. Please try to give your best work, study very well, and keep at home. إن شاء الله بنشوفكم بإذن الله سبحانه وتعالى.